Welcome. In this lesson, we're going to focus more on exponents than logarithms at the moment and how to solve exponential equations through a process called factoring, or sometimes called prime factorization. In other words, we're going to take each side and write them as a exponential expression, and we want the same base. Since the left side had a base 6, we want to try to write 36 as 6 as a base raised to some exponent. And then once we have the same base 6, the exponents must be the same. In other words, that exponent must be 2. But they will get harder. This one obviously is 0, because anything raised to the 0 power is 1, so don't forget that. Again, 0. Okay, here's one where it's a little bit different because there's an expression that we have to do. What I mean by an expression is I took the 27 and wrote it as a base 3 exponential expression to find out what the exponent would be on 3, and then I just made the exponents equal. In other words, I wrote this equation. The exponent of 3 must equal this exponent of x minus 1, solve for x, and we find out x is 4. And those equations will continue to get harder and harder as we move along. So again, with this one, I took the right side and made it as a base 5 raised to the 2 power, and the left side was also base 5, so 2x must equal 2, 2x must equal 2, x must be 1. So on this one, again, anytime we have a 1 on one side of an equation, we can write it to any base raised to the 0. So we have 4 raised to the 3x plus 4 equals 4 to the 0. 3x plus 4 must equal 0, and we solve, and we get a fractional answer for our x. When I go to put this in here, it's probably going to mess things up because I'm going to hit this, and I'm going to type in 4/3. Don't forget that it is a negative, so I'm going to come out here and put a negative in there. Oh, it didn't. Usually it messes up this stuff. But do you get the idea of how I'm setting the exponents equal? I'm going to jump ahead and see if they get any harder. Just remember, as we're moving forward, if you get a fraction of 1/5, we can write that as 5 to the negative 1 exponent. So be aware of your negative exponents. That will help you do some of these. Now this one, it's not the right side that we need to adjust. It's the left side that we need to adjust. So I adjust that 256 to be 4 to the 4th power, which is also raised to a higher exponent of 3x plus 3. Now remember, I have to multiply these exponents, so you're going to distribute the 4. So I actually get a 4 to the 12x plus 12 on the left side of the equation equals 4 to the 1 power, which means 12x plus 12, which is this exponent, must equal 1, which is this exponent. Solve for x. We get a negative 11/12 as a solution. Negative 11/12. And 1/11, 11/12. There we go. So again, just make sure you realize that you need to get whichever base is larger, usually to have the same base as the opposite side. So I want this 9 squared, but then I need to multiply in the x plus 4. I'll let you do that one on your own. And again, I'm going to jump ahead. So this one, I changed the 81 to 9 squared. That's raised to the 2x plus 4, remembering to multiply and to distribute. So I get 9 to the 4x plus 8 on the left equals 9 to the 2x plus 1. Those two exponents must be the same. 4x plus 8 must equal 2x plus 1. Minus the 2x over, get 2x. Minus the 8 over, get negative 7. Divide by 2, we get x is a negative 7/2. If you have any questions on these or come to one that I haven't talked about, please do bring your questions to class and I will help you.